Now let's take a look at the square root function. So you'll always know a square root function when you see it because it starts at 0 and it always kind of swoops over to the right there. Anyway, and let's look at what values you are allowed to plug into a square root. Recall that under the radical, it needs to be a number that is a positive number for square root. You can't have a negative underneath because if you did, it would equal an imaginary number, a non-real solution. So let's go ahead and start plugging in some values for x to see what we get out and then sketch our graph. So if we plug in a 0 under there, the square root of 0 is 0. If we plug in a 1, the square root of 1 is 1. If we plug in a 4, the square root of 4 equals 2. If we plug in a 9, the square root of 9 is 3. Notice I'm using perfect square numbers because if we don't use perfect square numbers, you can still find the square root of numbers that are non-perfect if they're positive. It's just that they will equal a decimal. So right now I'm using numbers that would produce whole numbers. Lastly, if we do the square root of 16, we're going to get 4. So once we go ahead and plot that, this is exactly what our graph looks like. Now let's take a look at some of the characteristics of a square root function. Where on the interval is it increasing, moving from left to right in an upward motion? And as you can see, that would be starting at 0 and then go on forever to positive infinity. There are no areas of decreasing on this particular function. Let's take a look at continuous. Can I sketch or draw this graph without lifting up our pencil? Yes, of course. From 0 all the way to positive infinity. That is its domain, which is starting at 0 and then going forever to positive infinity. Range. What is the lowest point this graph falls? And that would be at 0. Doesn't go any further down. Notice nothing is here. But because you have an arrow there, it's going to extend forever in positive numbers. So we would say our range is from 0 to positive infinity. So notice that all of these are pretty much the same. And that's just how it is for the square root function here.